So this is going to be the continuation of that chapter on electrochemistry, and basically we're doing example 19.2, and notice now we are in basic solution. Okay, so that means that we need to do steps 1 through 4 like we did before in acidic solution, but now after we're done with that part, we're going to continue and do step number 5, which says to note the number of H pluses and add this number of OH minuses so that they're equal on both sides. And then you're going to simplify the equation by noting that H plus reacts with OH minus to give water. So every single time you have an H plus and no OH minus on the same side of the equation, it becomes one water. And you're going to cancel out any waters that occur on both sides of the equation and reduce the equation to its simplest terms. So let's just really quickly go through as if it was an acidic solution and then do steps 5 and 6 to finish that out to make it a basic solution. So the first thing we need to do, like we did before, is to assign oxidation state. So I'm going to do that really quickly. Each oxygen is 2 minus. There are 4 of them. That gives me 8 minus. And because there is an overall charge of 1 minus here, so it equals 1 minus. The only way this is true is if this was 7 plus. Okay, so therefore this manganese is 7 plus. This oxygen, and again, is 2 minus, and there are 3 of them in SO3 2 minus, giving us 6 minus. And because of the overall charge of the 2 minus, this equals 2 minus. So therefore this must be 4 plus. Okay, so therefore this is 4 plus. Next we have this oxygen, which is 2 minus, and we're going to multiply that by 2 because it is MnO2, which gives us 4 minus, and because there is no overall charge, it is neutral. Therefore it must equal 0, so this must be 4 plus. So this manganese is 4 plus. And last but not least, this oxygen is 2 minus times 4, which is 8 minus. It gives us 2 minus, and therefore this must be, let's think about it, 8 minus 2, so this must be 6 plus. Okay, so this must be 6 plus. Okay, so let's just rewrite this again in blue. 6 plus, 4 plus, 4 plus, and 7 plus. I'm just going to rewrite this in blue so we know what it is. Plus 7 plus 4 plus 4 and plus 6. Okay, so now what we're going to do is we're going to bring down everything that we were looking at before. So we're going to go MnO4 minus, and it becomes MnO2. And remember, this is plus 7 plus 4. So therefore, to balance it all out, we need to add 3 electrons to this side. 3 minus 7 plus is 4 plus. All right. Next, we're going to do the sulfur, so SO3 minus, 2 minus, sorry, and SO4, 2 minus. And again, keeping track of the oxidation state of the sulfur, we've got a plus 4 here and a plus 6 here. So 4 plus, 6 plus, we've got to have 2 electrons on this side. 2 minus 6 plus gives you 4 plus. Okay. Now at this point, I would like to balance my electrons. So the electrons on the left side and the electrons on the right side, the gain and the loss must be the same. So I've got 3 electrons here, I've got 2 electrons here. The only way that this is going to balance is if there was a lowest common multiple of 6. So really, 6 gain, 6 loss, which means I need to multiply my top equation by, so I'm going to write this down in red. I'm going to multiply this top equation by 2. I'm going to multiply this bottom equation by 3. So that gives me 6 electrons on each side. So I'm just going to rewrite it all in. 2 times 3 is 6 electrons plus 2 times MnO4 minus gives me 2MnO2. And multiplying it by 3, I get 3SO3 2 minus and 3SO4 2 minus and 6 electrons. This allows me to cancel out my 6 electrons on each side. So I'm going to bring everything back down. I'm going to add everything. I'm going to get 2MnO4 minus plus 3SO3 2 minus gives me 2MnO2 plus 3SO4 2 minus. Okay, at this point we like to balance our oxygen and hydrogen count. So we've got 2 and 4 or 8 oxygens, and 3 and 3 is 9 oxygens. Together that makes 17 oxygens. 2 and 2 makes 4 oxygens, and 2 and 4 makes 12 oxygens. Together that makes 16 oxygens. So really we need one more oxygen on the right side, so I'm going to add a water because I need one more oxygen. So I need to add one water. So this gives me 2 hydrogens, so I need to add 2 hydrogens on this side, 2 H pluses on this side. Okay? So overall, that's my equation, and I would stop here if I was in an acidic solution, but I'm not. I need to be in basic solution, so I'm going to need to apply step 5. Note the number of H pluses and add this number of OH minuses. So I've got 2 H pluses, so I'm going to add 2 OH minuses. Okay? If I do it on the left side, got to do it on the right side. Okay? Actually, before I even add the 2 OH minuses, take a moment and think about it for a second. All the number of hydrogens, oxygens, sulfurs, manganeses are all the same on the left and on the right side. So if I added 2 OH minuses to get rid of the H pluses, because they will together form water, okay, then I've got to add the same number of oxygens and hydrogens, or 2 OH minuses. Otherwise, my balance of atoms would be thrown off from the point of where I balanced it in the acidic solution. Okay. So now, let's keep in mind that 2 H pluses and 2 OH minuses gives you 2 waters, right? H plus and OH minus gives you water. So if you have 2 of them, it gives you 2 waters. So I'm going to rewrite the equation. 2 waters instead of 2 H pluses and 2 OH minuses plus 2 MnO4 minus gives me, plus on the other here, 3 SO3 minus gives me 2 MnO2 plus 3 SO4 minus plus H2O plus 2 OH minuses. Okay? Now, it says in step number 6 to cancel any waters that occur on both sides. There's a water on this side and 2 waters on this side. I'm going to cancel out 1 water on each side. Again, I'm going to cancel out 1 water on each side. So that means that my end reaction is going to be, I'm going to rewrite it here, H2O plus 2 MnO4 minus plus 3 SO3 minus gives you 2 MnO2 plus 3 SO4 minus plus 2 OH minus. This is the final answer for this problem in basic chemistry. I would say this. I would say for every problem, it is the best to start with a clean sheet of paper, giving yourself lots of room, okay? Otherwise, you will end up making a mistake. It's easy to make mistakes with these kinds of problems. In fact, I would say this. If you do make a mistake, don't stress about it. I would just get a clean sheet of paper, start it all over again. totally normal in this kind of situations, okay? Especially if in the case where you make a mistake at the very beginning, then trying to change and, backtrack and fix things is impossible. It's very difficult. It's very stressful. So I would just say if you do make a mistake at the very beginning, let's say you assign a wrong oxidation number or a wrong oxidation state, or you add the wrong number of electrons to one side or the other, I would say don't stress about it. Take a deep breath, get out a clean sheet of paper, and redo it again. It's not a big deal. We've all done that. We've all had to do it. It's part of the learning process. In fact, even now, sometimes if I'm super tired and I'm doing a problem, I lose track of an electron or I lose track of a number of atoms, I just start over a brand new sheet of paper. All right, I'm going to do one more example in basic solution, and then I'm going to stop the video, and then you can continue on with the next video for applications. So, basic solutions, here we go again. And now this is very important to remember. H2O2 is hydrogen peroxide. So this means that this H, because it's bound to a nonmetal, it is 1+. And there are 2 hydrogens, so it gives me 2+. And because there is no charge here, it is neutral. Okay, it must equal 0. So the oxygen must be 2-. And it is not one oxygen is 2-. It means that there are 2 oxygens and they equal 2-. So it must also be 1- for this to be true. So in this particular case, for oxygen, the oxygen is actually, each one is 1-. This is our special oxygen situation that we had talked about at the very, very beginning. Now this oxygen is just normal oxygen, 2- times 2 is 4-. So this chlorine is 4+. Okay, next, need the black marker. So then we need, this oxygen is 2- times 2 is 4-. But notice the charge is minus, so it is actually 3+ here. Okay, and last but not least, this oxygen is elemental. It is all by its lonesome, so it must be 0. All right, so if we're doing this all the way through, we're going to go and do our half reaction. So we've got, or I'm going to do it here actually, H2O2 gives you O2. Okay, and remember, this oxygen is 1-. This oxygen is 0. And each oxygen is 1- 0. So if you had, for example, 1O1- and it becomes O neutral, the only way for that happens is you've got 1 electron on this side. You guys see that? Okay. However, you have 2 of them, right? So really it's 2, sorry about that. It is 2 1-. So if another 1-, becomes oxygen neutral, then you need another electron for this. So really this is 2 O1-. So I'm going to go 2, 2, so 2 electrons. Again, I repeat again, each oxygen loses 1 electron. Each oxygen loses 1 electron. Because there are 2 oxygens in H2O2 becoming O2, that oxygen must overall lose 2 electrons. Each one loses 1, but overall you lose 2 electrons. Hopefully that makes sense. Okay. You have ClO2, and it is becoming ClO2-. And again, this Cl is +4, this Cl is +3. Now there's only 1 chlorine here, unlike the previous half reaction, so really you just need to gain an electron on this side. Okay, So that together is nicely done. Okay, but notice this bottom half reaction has only one electron, and you have 2 electrons here. The only way to balance this out is to multiply this bottom reaction by 2. So we're going to go 2, 2, and 2. Okay. Then at this point, we're going to bring everything down. So we're going to cancel out our 2 electrons. So we've got our H2O2 plus 2ClO2 gives me O2 plus 2ClO2 minus. Okay, so let's keep track of the number of oxygens that we've got. Here we've got 2 oxygens. Here we've got 4 oxygens, so that's 6 oxygens total. Okay. 6 oxygens total. Here we've got 2 oxygens. Here again we've got 4 oxygens. So 6 oxygens total. So the oxygen count is balanced. Nice. The H hydrogen count, there are 2 of them here, so we need to add 2 hydrogens to this side. Okay? And if we were doing it in acidic solution, we would be done at this point, but we are in basic solution. Okay, we are in basic solution. So we want OH minuses, no H pluses. Again, we apply rule number 5. Wherever we see an H plus, we're going to write the equivalent amount of OH minuses. And if we write it 2 on the right side, we must add 2 OH minuses on the left side. And again, the reason for that is before we've written the OH minuses, the reaction is balanced in terms of the number of hydrogen, oxygen, and chlorine. So if we write 2 OH minuses, we've got to balance it by writing 2 OH minuses on the left side. And for every place where there is H plus and OH minus, we're going to replace with water. So in this case, this is 2 water. So pretty much we're going to bring everything down and then we'll be done. So we've got our 2 OH minuses, our H2O2, our 2ClO2 gives us O2 plus 2ClO2 minus plus 2 water. Okay, and at this point, this is the final answer. And again, just to remind everyone, we are in basic solution, and since we have OH minuses and no H pluses, we are in basic solution. Okay. All right. Hopefully this makes sense. Let's do one more thing. This O2 2 minus situation here that we have with the peroxide is a very special case. We've got our O2 2 minus, right? Which means that each oxygen is 1 minus. Okay? This is the same thing with what we have when we have Hg 2 plus. In case you see this on the homework, that means that each Hg or each mercury is 1 plus. Just keep that in mind when you're doing your homework. All right. I'm going to stop this video here, and I would go and do the next set of problems in your homework